off with our discussions, I'd just like to welcome our panel of experts. We have Mark Poutney, Technical Manager from Chalmette.
Good afternoon, everyone.
We've got Ken Edelston, Senior Lighting Specialist from Chalmette as well.
Hi, folks.
And we have Sean Rogers, Lighting Product Manager from Killark.
How's it going?
All right, thank you very much. Good waves, everyone. So, first question. How do we ensure that we can achieve the maximum lifetime of components within an LED luminaire? Mark, do you want to kick us off with that one?
Yeah, thanks. That's an excellent question. As I said, the primary concern is that we must maintain a safe product. So in that end, we're making sure that every component that we assess operates within the tolerances expected of it. We carry out, obviously, extensive testing through our certification process for both hazardous and our industrial products. This includes thermal rise testing, conditioning testing, which live test components to the very end. So it's an accelerated aging process. We have EMC testing. We have our own IP testing. We have impact testing. We have the full suite of testing that would be required for any particular product. But if we look at the components on their own, we use only A-grade components, and we split that into two levels. We look at both the driver, if we're talking about LED products, and the light engine. Within the driver, we can have components such as electrolytic capacitors that are very temperature sensitive at the top end. So what we don't want to do is make sure that we reduce the life of our products by exposing it to temperature when we don't need to. With the LED chips themselves on the light engine, what we're looking to do is give the most efficient and best light output possible to the end user, but again, keeping it within the thermally managed parameters.
Yeah, and just to add to that, so Killark probably, gosh, it must have been 3, 4, maybe even 5 years ago. We invested a couple $100,000 in a halt chamber. Okay, and what a halt chamber is it's a highly accelerated live test. Because we were, whenever LEDs were first coming about, like 8, 9, 10 years ago, we were taken aback with all the options that we had with drivers. Once a lot of people started getting into the game as manufacturing components. So not all of these components will withstand the temperatures required. So hazardous location is unique. In industrial applications, you'll usually have like coolers, which are really cold, or you'll have high heat applications. Hazardous location, we have to accommodate for both in one product. As you can imagine, that's pretty difficult. So as on top of all the testing that Mark has mentioned, we have to make sure that the components are the top tier, as he said, top A level components. So we've seen some funny stuff where drivers melt in this test, because what we'll do is we'll take it well above the required limits of the driver, and not just thermally but also electrically. So we'll cycle it high voltage, low voltage, hot, cold, and literally try and destroy the components. And last thing is we have a big sister in Hubbell Lighting. They're huge company, huge lighting company, and we do lean on their expertise as well and the things that they've done. We have a back and forth with their engineering team to make sure that we're on to something that they're on to, or vice versa, right? So just to share data and best practices.
I mean, to elaborate on that as well, from my perspective, it's really, while there are a lot of established lighting brands out there, that doesn't necessarily mean that we can use the same components. As the guys have already touched on, these are extreme environments, harsh conditions. So we have to take it that one step further between both the sides, both the Killark and the Chalmette brands.
Yeah, if I can just come back in for one final thing. Products not only have to operate within a set tolerance, but they have to fail within a set tolerance as well for hazardous area. And this is we've had a couple of instances where we've tested products up and beyond the limits that were suggested for the product. Now, at the time, going beyond a limit of a product, some people think, oh, that's great, our product's done really, really good there. But for us certifying a product, that can become an issue. because we have to tell the certifying body when our product will fail, at what temperature, at what voltage, and all those criteria have to be met. So a product operating beyond its limits is sometimes as much of an issue as a product that fails before its limits.
Perfect. Thank you very much for those responses. I mean, do any of you want to add anything in terms of how you incorporate that on top of certification? Anything more you'd like to add about how you'd incorporate achieving that maximum lifetime of components and LEDs via the design? You've mentioned thermal management there slightly, but maybe we could expand on that a little bit.
Yeah, so you know, I used to be a design engineer, so I guess I can touch on this. I know Mark, this is his expertise, but you have to make sure with LEDs especially, they are very, very sensitive. You know, they're electronic components, so you have to make sure that you have the thermal design right from the get-go, because if you have hot spots on your product where you know, the component gets hotter than what is required or what it will withstand, that's a big no-no. You know, you'll see it where they'll fail. You'll see, you know, back in the original days of LED, you'd see chips actually falling off of circuit boards. So you have to make sure that you have a very streamlined and efficient thermal path, because you know, the product itself takes the heat. You need.
Oh, I think Sean has frozen there. Unfortunately, the issues of doing these things live, the joys.
He's got too hot.
Yes, he has.
Well, I mean, what I can.
Yeah.
I mean, what Sean maybe didn't mention there is, or for those of you that aren't familiar, is that he has gone over to the dark side these days. So he is fully invested in sales and marketing, like myself. And certainly the challenge that we have from both Sean and myself, and we have to give Mark and his team, and conversely Ray and his team over in Killark, the challenge of achieving the targets and the lifetimes that us and our customers expect these days. So we push the boundaries from a sales perspective and what the market is looking for, and Mark kind of has to follow through with that. And the way they're really doing that is through design of the components, through design of the housings, designing the enclosures around the technology available to us now, ensuring that you've got a direct thermal pathway to the environment. Sorry, Sean, I kind of took over there.
No, yeah, my teams just said, "Hey, goodbye," and shut down. Sorry about that. So I don't know where I cut off, but the tail end of what you said is what I finished with. So.
Okay.
I think on the back of that, what we need to consider is the differences now on design between LED products and our legacy products, which were fluorescent and HID. We get a lot of questions, specifically on the linear style product, why we moved away or do move away from a polycarbonate or a plastic style body towards more of aluminium or metallic bodies. And the reason for that is thermal management. The products operate slightly differently. Before, we had electronics behind the product and a light and heat source that threw everything forward. Now we have electronics behind the product and a light source that throws light forward but heat backwards towards the electronics. So we have to be very careful how we manage that. And within a non-metallic enclosure, we find it very difficult to balance that heat.
That's great, thank you. Sean and Ken, do you have anything you'd like to add to that?
No, I think you covered.
No, I think that's good.
Yeah, thank you for that, Mark. You kind of brought us, you mentioned conventional kind of traditional products there, which brings us on quite nicely to our next question. What are the key benefits of using LED luminaires over their conventional equivalents? So Ken, if you want to pick up on that one.
Yeah, I mean, there's obviously quite a few features that I'm sure you of. Probably the most common one is the reduced power and increased lifetime. The LED technology and the components that are utilized with that. Essentially, your complete LEDs. Hopefully, most of you on this call are aware that LEDs really can, you know, to achieve the sort of 2 hour plus.
Uh-oh.
You still got me?
kind of.
Apologies, everyone. We seem to be having a few connectivity issues today. I think you're back now, Ken. So if you want to carry on.
Okay. Well, hopefully you heard the expected lifetimes that you can get out of components these days. In LED products, LEDs themselves can easily achieve an L70 lifetime much greater than 150, 200,000 hours. Most LED drivers, the maximums we're kind of seeing at the moment around about 100 to 120,000 hours. I think as a sort of minimum benchmark, people are at least looking for the 100,000 hour life out of components or out of an LED luminaire. Okay, 100,000 hours, for those of you not doing the quick maths in your head, that's roughly 12 to 13 years. So it's pretty significant numbers. Over the course of a project, that potentially means you only need to maintain it once or twice at the very most. In the case of some of our newer LED products, namely the Protector X, I mean, we're making energy savings there of 50%. It's significant now. So what that then leads to is reduced loadings, not just on the number of luminaires that you'd have on your circuits. You can have extended cable runs. You can have more products on those cable runs, but also on the distribution boards that you'll have on site. That means you can reduce the number of circuits that you're going to need to maintain going forward over the time. So all of this adds to the green credentials really of looking at an LED product and looking for an LED solution. Yes, LED products in general are still more expensive, but the thing to bear in mind is that the sourcing of conventional components is going to become more and more difficult. Everyone is looking at ways to be, well, not just be seen as green, but also looking to achieve the targets of net zero. This seems to be a massive focus in the industry going forward now, and hopefully all of you are seeing this as well. To add to that, sorry guys, I might be waffling a while here. To add to that, I'm sure you're all pretty familiar with the directional nature of these. So that has good and bad points, absolutely. I'm not going to dispute that. But the sort of stance we've taken on our products now is to try and utilize that light as efficiently as possible. Focus it where it needs to go. Okay, you're trying to minimize light pollution. You're trying to minimize sky glow. In some cases, spill light is desirable. I'm not going to dispute that, but you need to control it. And I'm sure a lot of you on this call are also hearing more and more about the environmental aspects of lighting as well. Trying to make sure that you're not causing any issues with migratory birds, turtles as well, to name another creature out there. So all of these things need to be considered as part of the product and part of the solution that you're trying to achieve. Final point I'll add is about performance of the product. Now, strictly speaking, not all LED products will have a greater output than their conventional equivalent. Okay, but there are pros and cons of that. You will find that most, if not all, LED products now are more efficacious. So you have your higher lumens per watt value. Probably if you asked us 5 years ago, that definitely wasn't the case. You still had some conventional HID products out there that were still competitive. That has now been dramatically overtaken by the performance of LED products out there. So improved performance, directing it where you need to go, can potentially lead to a reduction of quantities over your entire site. Reduction in quantities means a reduction in weight, means a significant reduction in power, means a reduction in installation time, and the reduction in the number of equipment that you need to go hand in hand with that. So reduction in cable glands, reduction in junction boxes. Hopefully you can see where this is going.
I guess the only thing I can add to that is expounding on what you talked about with the amber and green LEDs. This was not possible with traditional lamp sources. So specifically, I co-authored a paper with Marty Cole, Monica Dijon, and Logan Hughes, who are part of the Kilarc side or the North American side, and it's for PCIC. And what it is it has to do with the imprint and ecological effects that we have on these sites. So specifically, we have a few in Florida where if they're near the Gulf Coast or any coast for that matter, you have to be cognizant of the light spill out into the ocean because the baby turtles will come out of the ground and they look for the brightest celestial being, which it sometimes happens to be a light fixture that's in the middle of the plant. So it leads to increased predation on these little turtles. So this was not possible before LED came about. So now we can actually tune it to be, the wavelengths that that are not, attractive or conducive to these animals. So they're completely innocuous. The turtles or the migratory birds don't even see these colors. So that was completely impossible back, before the advent of LED, or it wasn't practical. They would put tube covers over and things like that just didn't do the job. So that's the primary thing that we see now. Great
response. Just a reminder, guys, I mean, if you have any questions as we go along, please feel free to pop them in the chat. And if you could just make sure that your cameras are off as well. So kind of, Ken, moving back to what you mentioned earlier about reduction in luminaires, reduction in energy costs. We did have a question from Ang Yin from PECI. Apologies if I've not pronounced that correctly. Just talking about the initial cost investment of LED versus the long-term cost saving that you can potentially expect. So could we talk about how LED technology could minimise the OPEX cost required for lighting as well a little bit more?
Yeah, sure. I can elaborate on that a little bit. Obviously, this is coming back to trying to achieve a more carbon neutral, or trying to be more energy focused and environmentally aware. And trying to reduce your overall operational expenses on your facility or your site. It all pretty much adds on to what I was alluding to in my last response. So you have fewer products potentially, reduced weight, but the fewer products would mean less accessories are going to be required with those products themselves. So again, less cable glands, less junction boxes, longer cable runs, so you only have one circuit to meet the requirements. All of this means you've got fewer products, fewer components, fewer accessories across your entire facility that you're going to need to inspect and maintain over the course of the life of both the products and the facility itself. Longer life, of course, means less maintenance. So the advantage of LEDs in terms of the lifetimes that you can get from the light source over your conventional equivalents is significant now. I think historically, the sort of longest lives we could get out of conventional components would be around about 48 to 50,000 hours on an HID versus 80,000 hours on a fluorescent. For a long time, those were phenomenal, but LEDs have dramatically overtaken it. And from my point of view, it's almost a no-brainer now to look at that as a solution across your facility. The other point maybe is regards to emergency design. So potentially you will have less draw from a battery system. So whether it be integral, or whether it be a UPS or a centralized battery system, your LEDs will require less power to generate a similar lighting level in emergency conditions to ensure safe egress across your site. So all of these can help increase the overall output of your emergency or the duration required for safe egress. Okay, typically that's 90 minutes to 3 hours. All of this, though, is for the bigger picture, is to help reduce your total cost of ownership. So reduced installation, reduced maintenance, reduced weight, reduced total cost of ownership on your facility.
Yeah, I think just to add to what Ken was saying, what the difference between LED and traditional products, the output operates very differently according to temperature. Traditional products didn't mind the heat, but didn't like the cold. LEDs, on the other hand, are kind of the opposite way around, but with thermal management and thermal foldback, we can mitigate the risk at high temperature, but we can also guarantee a much better output at low temperature. So for the large projects in the areas of the world where temperatures go below zero for large portions of the year, we can now cut the number of luminaires that they need to use in that area due to the fact that the light output will be significantly improved.
Yeah, that's a very good point, actually, and I want to just highlight fluorescent lamps in that case. Fluorescents really do not operate very kindly in cold temperatures. I think once you go below 20 degrees Celsius, you will notice significant drop-offs. I think down at -20, you could potentially get around about 20 to 30% output of that tube. So you will not be getting anywhere near the lighting levels that you would expect at low temperatures.
Great points. Sean, do you have anything to add there?
No, I think you guys covered it.
Okay. Well, we'll move on to our next question then. What conditions/factors can affect the lifetime of LED luminaires?
I think that one's for me a very short answer. The over voltage and high temperature. We don't like either of those. Over voltage, obviously, we can do instant damage to components, which may not fail at that time, but will do over a reduced period of time. Temperature itself, very high temperature can reduce it. As I mentioned earlier, electrolytic capacitors. If you take an electrolytic capacitor for, say, every 5 degrees above 80 degrees centigrade, you almost half the life of that electrolytic capacitor. So if you have a 100,000 hour driver at 80 degrees centigrade, at 85 it becomes a 50,000 hour driver, at 90 it becomes 25,000 hours, so it's significantly reduced. So that's why we have to be very careful and manage the thermals on the product through certification.
Perfect. Anything that you guys would like to add to that?
No, I mean, I guess this again ties back to what we discussed before about design of the product and ensuring that you've got that thermal pathway, efficient thermal pathway out to the environment and dissipating the heat as efficiently as possible. It's kind of key to LED products in general. Yeah.
I mean, one question we did receive via the form was about whether you can have a luminaire like the Charmit Protector 3 in 24/7 operation. So maybe we could talk about that as well.
Yeah, I mean, that's sorry, that was a Protector LED, was it?
Yes, it was.
Okay. Yeah, I mean, that's probably more interesting in my mind is the conventional side of it. So if you look at conventional lamps, they do not react very well to switching cycles. In fact, the more switches over its lifetime it incurs, the shorter the life of the component itself. LEDs don't have that same sort of restriction. I mean, while we wouldn't necessarily encourage you to use that luminaire 24 hours a day with the environmental hat that I'll be wearing for this brief conversation, but there is no issue with leaving it on 24 hours a day, 7 days a week. It doesn't have the same restrictions of a conventional product.
And from our perspective, in the Gulf Coast specifically, they used to keep the lights on 24/7, so kind of going the other way, just for what you mentioned, but also for the added effect of it's extremely humid, and whenever you had the HID products lit and turned off, they actually created a significant suction pressure, right, or negative pressure that would draw in moisture into the fixtures. And it's not uncommon now today to walk around and see globes, not LED, HID globes, full of water because they just soak in all that moisture. It's not from leaking pipes or anything else. It's most of it's from water coming in through humidity. So with LED, you're not nearly as hot. It's a lot cooler than like if you look at the T code temperatures, which is just the hottest component on the fixture, it's much lower than what you would see in an HID and non-restricted breathing HID. So you can turn the light fixtures off if you need to, and without the fear of them gaining moisture.
Great. Thank you. So the next question we've got on here are, what are the key metrics customers should be aware of when specifying/selecting an LED luminaire for hazardous area locations? So Sean, if you want to kick off with that one.
So, the number one is make sure you have the right product for the right location. I mean, that's the key specifying metric that you need to look for. You don't want to put a zone 2 light fitting or luminaire in an area that needs a class 1 div 1. It doesn't work that way. So that is the key is work with your, we always say the authority having jurisdiction or your engineering firm or even your insurance company, and they'll tell you what area needs to be specified or what the area is specified as. And then you can start your search, so you're kind of, using funnels. After that big funnel, you go down and you think, well, what is the ambient? What is the max ambient that this area is going to be, subject to? So, as Mark mentioned before, that is a huge key determinant, because if you have a product that's only listed for 40C and you're in a 65C ambient, it's not going to last very long. You know, we put in parts in there, specifically thermal foldback, to try and mitigate some of that over ambient, but a lot of times we'll hear, you know, well, it's only 80 degrees Celsius. Well, it's 80 degrees Celsius here at your work plane. If you were to look, you know, wherever the fixture's mounted, a rule of thumb is it's a degree Fahrenheit. Sorry for anybody you know, isn't on or is on the metric system, but a degree Fahrenheit for every foot that you go up. So, you know, 100 feet in the air, you're adding, you know, potentially 100 degrees Fahrenheit to the temperature. And so whenever you're specifying, take, you know, they have those little laser heat guns, point it at the ceiling and see what that temperature is at the roof, and use that as you're specifying ambient. And then the last kind of thing is your ingress protection rating. We do have a few products that are submersion, you know, can be submerged. They're few and far between, but I know we had a job down in, I think it was Louisiana, where they had a dock that they lit, hazardous location, but then it flooded every season, you know, and these luminaires are actually subject to being splashed down and under the water. So, you know, that's not IP66, you know, that's a IP67 or IP68 condition. So again, ambient and then ingress protection are my two key considerations.
Ken, what about you or Mark?
Yeah, to elaborate from the IEC-EX perspective, Sean touched on the protection concept they're going to require for the product itself. That can also have a massive impact on the performance of the product. So depending on the protection concept or SEPs that you've employed on the luminaire itself, the main example I'm thinking of is an EXD product versus an EXE product. EXD luminaires historically are very heavy, very robust, designed to contain an internal explosion, essentially, whereas EXE eliminates that from even happening, which potentially means that you can reduce the size, the weight, the thickness of material that's in front of the LEDs, for instance, so which leads to a better performing product, potentially, a lighter weight, better performance.
Yeah, I think the only thing I would add to that, I agree completely with what the guys have said prior to me, but purely from a design point of view, we can only design and make new products for you if you feed the information back through our sales team as to what you're going to need for your projects going forward. It's pointless, my guys in an office in Glasgow coming up with a design for a plant in Malaysia or the US or Australia or somewhere else in the world where they have no understanding. So the information has to come back from you guys, and the sales guys will feed it back to us.
Perfect. Yeah, really good point. Okay, Ken and Sean, anything else you would like to add, following on from Mark's point there?
Not for hazardous area products. I think those are kind of the key points on there. If you're talking lighting in general, hopefully everyone's aware of your lifetime metrics on products, whether that be your L70s, your L80s, or your L90s. For those of you that aren't, that is the time to get to 70% or 80% or 90% of initial lumens on the luminaire. Okay, so this tends to be a key lifetime metric that people are using to compare products across all manufacturers.
Mm-hmm.
I think one thing I would add is it's very difficult. We get asked the question a lot, hey, what should I use in this application? You know, I have a 400 watt metal halide, or I have a 400 watt, you know, whatever, a high pressure sodium. I always recommend doing a lighting design. You know, send us some drawings. I don't care if they're sketched on a napkin. I have some brilliant lighting designers that you know work for us, and Ken, you have the same, and they can work magic, because if you have a very specific requirement, so in NEC we have OSHA requirements where you have to have a certain foot candle level, lux level on the ground, and if you fall below that, you're subject to fines, and it's a dangerous work environment anyways. So especially with big applications where you're changing over an entire facility, or even changing over a whole tower or something, you know, do a lighting design on the front side. Our guys typically will turn them around. In fact, I just got an email from him, gave him one last night, and he already has it turned around. So they're usually less than 24 hours that we can turn around a lighting design, and then that way you're going to know exactly what you're going to get whenever you install the light fixture.
Yeah, that's a really good point. Actually, it's we often, when people ask us about what is the equivalent to, it's never a straightforward answer, as Sean's alluded to there. It's, we would use as a starting point your lumen outputs. So you could have your LED lumen output versus a conventional, but there's more to it than just that. It's where is that light going? And that kind of touches on a previous point that we made with regards to distribution and getting the light where you need it to go. By using lighting design, you can optimize your facility as much as possible and potentially reduce your quantities even further.
Mm-hmm.
Yep.
Great, thank you. We've had a question in the chat from Joe asking about getting drivers that are 12 to 24 volts and whether the demand is there.
I know why he's asking. So 12 to 24 volts is you in the UK, you probably don't even have that, right? It's very common in Canada and it's very common in the Gulf Coast to have these, and unfortunately manufacturers, it's not very common. So we are working on actually designing our own drivers. So it's kind of a very product specific question, but we are going to be designing our own 12 to 24 volt range of drivers to satisfy that demand, because it's very odd and it's very specific to North American markets. But to be honest, I don't even know where they're putting them. I don't know if they're putting them on trucks or something, but yeah, we are working on that presently.
Yeah, we have a limited requirement for that kind of thing too, and it's very product specific.
Perfect, great. Thank you for your question, Joe. Apparently for skids in the oil fields in Canada.
Yeah, there we go. I learned something today.
Thanks again.
I got trained.
And for everyone else, please don't be shy. Please put forward any questions that you've got in the chat there. We've got about 10 minutes left and we've got a few more questions that were submitted via the form to cover. But if you have a burning question, please don't hesitate to ask it. So the first question, one of the other questions that we've got is, could you advise in the application of flame-proof and explosion-proof fixtures and what the differences are between the two? So Mark, if you want to cover that.
Yeah, those terms are fairly interchangeable. We hear it quite regular. People who mean flame-proof say explosion-proof, or those who say explosion-proof mean flame-proof. That's not easy to say fast. The main difference is that flame-proof is mainly aligned to the US standard, which would be the ANSI UL 1203. And the explosion proof is more in line with IEC 079-1, which is the European spec. I would say in the flame proof would be classed as almost a class 1 product, and explosion proof EXD, if we're talking that way, would be a zone 1 product. So that's where we hear most of that, but those terms are mainly interchangeable.
From an NEC perspective, everybody asks for explosion proof, and what they often mean is just hazardous location rated. So explosion proof is, as Ken mentioned, for NEC side is like a zone 1 EXD. So you have like class 1, division 1, thick flame paths, and a little bit more expensive fixture, right? Because it actually has to contain that explosion without igniting the surrounding atmosphere. So from us, explosion proof is a pretty generic concept, and typically we would prefer to hear it in like the zonal system or the class and division system. But the best way is just call us. My phone's always open, my email's always open, and we can have a quick conversation about what it is. Now, I'm not ever going to tell you what you need. I only take the information that you give me and tell you what products we had to satisfy those requirements, but I might be able to help you through some of the terminology that is commonly used.
Great, thank you very much. Anything else that Ken or Mark you'd like to add to that? Okay, thank you, Clayton, for your comment in the chat there about the applications for that. We're certainly getting more knowledge about where that voltage would be used, so thank you very much, and those drivers.
Yeah, look, on the back of what Clayton said there, you can see he's got a class 1, division 1, zone 1. We're seeing more of that. It's almost a crossover standard, where people are almost looking for a combination of the North American and the European standards. So it's something that we could spend a whole question and answer session on would be the certification side of things.
Yeah.
But this is something that's becoming more and more familiar now to the guys in the field.
Yeah, absolutely. To the point where we've even designed our products to be quad listed, because a lot of times they don't know where these are going. So yeah, it's a very difficult task though for the engineers to kind of merge the dissimilar certifications and design one body of products. But yeah, I mean, honestly, the output of this, we should have another call just to discuss certifications, because you could have an all-day training on it and still not, touch all aspects. So.
Absolutely. Thank you for that point there. So I'm gonna move back to one of our questions on the form as well. This was from Fadila. We have encountered luminaires with signs of moisture inside due to condensation, as the area has high humidity. How can the new LED luminaire address this issue, as for our asset, once there is moisture inside the luminaire, its hazardous area certification will be voided? Now, you mentioned earlier a little bit, Sean, about moisture inside there. The bit I would be maybe want to focus on is the certification element there being voided.
Sure. So the first off, as I mentioned before, right? So LEDs aren't as hot as their conventional counterparts. So you're not going to have that same draw. Now, if you have pipes that have, open ends and things like that, you will have issues, just as you would with HID. But I think that this is exacerbated with HID and kind of tampered down with LED. So you don't have that draw, that same moisture draw. However, with certifications, if you have subtle condensation, that does not void your hazardous location ratings. If again, I don't want to get into the nuts and bolts of the IP testing and everything else, but essentially you can't have significant amounts of water that will hinder or hamper the operation of the device. So if you have water droplets and things like that, that's really not an issue. It does not void your certification. Now, if the thing's full of water and it arcs out and sparks, it's an issue, right? And it's most likely going to be open conduit is what we see is probably the most common sign of that. But no, it does not void your certification just by having water droplets or subtle moisture inside the fixture.
Great, thank you very much. Mark, you're looking like you kind of want to say something there. Are you all good?
I'm completely in agreement with Sean, where the moisture in there, there is a preset number that you have to reach before you would void the certification, but having a degree of moisture in there does not automatically void the certification.
Okay, perfect, thank you. Well, I'm just going to move on to the next question. How does the luminaire respond to voltage dips? As in our plant, the voltage can dip from a nominal voltage of 440 volts to 390 volts for 5 seconds during a big load start. Will this affect its lifetime if the voltage dip is frequent?
I wouldn't say so. I'll take that one because we're looking at roughly a 5 to 10% drop there on the standard voltage. So all our product would be tested to plus or minus 10% on the voltage requirements. So that level of drop would be well within the tolerance of the product. What I would say is we mark the product to plus or minus 10%, but we have to test up and beyond that in order to guarantee the functionality of the product. So those kind of numbers, I would say, would have limited, if any, effect on the product at all.
Yeah, and from KILARC's product, that would be like a 480 volt, 347 to 480 volts. So we catch Canada on the bottom end, and then the high-end transformers on the top end, and that would be no effect at all. Now, whenever you start going from like a 120 volt rated fixture down to like 90 or 80 sometimes, that's issues, right? What you're going to see is you're going to see an increased stress on the components in the form of heat. So the varistors, transistors, whatever you want to call it, they're going to have a problem with that, and they're going to heat up, and that's going to decrease the life of the product. But no, I mean, we had a lock. I like using these examples that I've seen, but we had a lock and dam actually here in Missouri, where the plant is, near the plant, that had very similar, except for it went from 240 down to like 80. That's an issue. You know, that's the fixtures, you know, that they just cannot take that. They do have electronic components that have to have a certain range, as Mark said. But if you're within 10%, even for us 15, you're probably gonna be okay. But anything more than that, that goes below the limits that we rate, will have an issue.
Okay, great, thank you. We've just got a comment here in the chat from Jeffrey as well. I believe we have a low voltage range of the HDL 106 series that's able to operate at 18 to 54 volts at AC/DC. Ken, do you want to comment on that?
Yeah, I mean, he's absolutely correct. I mean, we do have the HDL. We also have the NextLED as a 24 volt solution. So LED bulkhead.
Perfect. Thank you very much. Well, those are all the questions that I had, and we're just about at time. So unless anyone else has any questions that they wanted to bob in the chat quickly, Ken, Sean and Mark, did you have anything else that you wanted to raise before we close off the session?
Not besides, if you have anything else, you know, or you don't want to speak in this forum, just reach out to us directly. You know, as I mentioned before, our phone lines are always open, or our emails are always working. So send us a shout and we can maybe have a conversation to expand upon something that you have a question about.
Yeah, and from my point of view, just grateful that everyone could join and really appreciate the questions that were put forward to us.
Perfect. Yeah. Thank you very much, everyone, for joining. We will aim to get the recording out of this so that you can review it as soon as possible. And, you know, we mentioned that we'll potentially be doing another session on certifications potentially next time. So we'll let you know about that as soon as we can. Thank you, everyone, for joining. Bye.
Thanks, everyone.
Bye, guys. See ya.